A bearing is an angle measured clockwise from north, which means when we measure bearings, the zero of the protractor, 0 degrees, should be put at north, and then the turn clockwise should be measured. The fact that we measure bearings clockwise is important. So bearings are a real thing, and bearings are particularly used in navigation, especially in planes and on ships. The idea is that if everybody is measuring an angle from north, everybody is using the same system for calculating their position. You are a certain number of degrees from north. In particular, if north is 0 degrees, 90 degrees from north would be east, 180 degrees opposite north, south, 270 degrees would be west, and then 360 degrees will be back at the 0 of north again. And if everybody is using that same system, then everybody knows where everybody else is. It's not that some people are measuring from north and some people are measuring from south or whatever. Everybody's measuring from north and everybody's measuring in the same direction. So bearings are used to give a direction in navigation. Couple of things we need to be aware of with bearings. So we need to be able to measure a bearing. We need to be able to look at two places and give the bearing of one from the other. And questions will generally work in that way. Measure the bearing of a particular place from another place. And when we do that, we have to make sure that we are focusing on the location we are measuring from. And that from word is the most important word in the question. So we need to have our protractor with the 0 pointing north and the location that we are measuring from. And the other thing we need to be aware of with bearings, that bearings must be given as 3 figures, 3 digits. So if we were, say, 60 degrees from north, we'd have to write that as 060, 060. The only reason for that is because bearings tend to get entered into navigational computers. And if everything is working with 3 figures, there is no chance that the computer could accidentally misread something. If you were to put 60 into the navigational computer without the 0 on the front, the computer may not know whether to keep that as a 60 or whether to shift the 6 into the hundreds space, put the 0 in the 10 space, and then turn it actually into 600. And 600 degrees and 60 degrees are very different. But if the computer is reading it as 060, it will definitely get the place value right and nothing will go wrong. So whenever we are reading 3-figure bearings or writing 3-figure bearings, we have to be putting that 0 if it's a 2-digit number. Let's have a look at a couple of examples. Now for any bearing question, if we're focusing on 2 places and we're looking at the bearing of one from the other, we want to have a line joining the 2. So we grab our rulers, we draw a line. This particular question, the line is already drawn for us, which is very generous. If it wasn't, we would draw the line in. The other thing that's drawn for us are 2 upward pointing arrows with an N written on them. Those 2 arrows show the direction of north. Again, if they were not there, we would have to draw them on. Generally speaking, they will be drawn on, but they may not always be. North will generally point up in these questions, much like when we were talking about the compass directions the other week. The north arrows tend to point upwards. So we've got 2 places joined with a line. This one is drawn for us. If not, we would draw that line in. And we've got 2 north arrows, one from each point. And part A goes, measure the bearing of B from A. Now the important part of that question that we are going to pick out, well, we see the word bearing, we understand it's a bearing question, and bearings are angles measured from north, clockwise from north. But the key thing we need to pick out of that question is that word from, or more particularly from A, because that tells us where we are starting. In this particular question we are starting at A because we are going from A. So we need to measure clockwise from north, so we're going from here until we get to the point where B is. Now that is what this line is for, because for A we are measuring clockwise from north, so we are measuring this turn here. The turn from north clockwise in the direction of the clock until we're pointing at B, so we are measuring that line drawn in there. And that is what we are going to measure. So that is the angle we need to measure. Now we need to measure that angle so that the 0 is at north. So we get our protractors. And we place our protractor on the page so that the cross of the protractor is at the centre of that angle, at A, in other words, and that this line with the 0 on is on the north line there, because we need to be going from 0 at north. Then we're going to read round, starting from the 0, so we're on the outside scale this time, until we hit this point. Now the problem with this is that it is actually slightly too small for us to really properly see what's going on. Well, that's okay. Why don't we just extend the line? Yes, we can do that. The angle does not change if we make the line longer. So I'm going to extend that line a little bit so that I can easier see what I'm doing. So my protractor goes on, cross at A, and the 0 at north. I'm going to read round until I hit this, and on the outside scale, 110, 115 there. So my answer for the first part will be 115 degrees. It is a 3-figure number, so that's okay. Part B then says, measure the bearing of A from B. So again, this time the from B is the key part of that question, because that tells us our start point. So we need to measure round from B until we are pointing at A in a clockwise direction. Now it has to be clockwise, remember. So we are going to measure all the way round here. And that outside angle, because we have to be going clockwise, is the one that we're going to measure for B. So again, we have got options here. This is a reflex angle, so we are going to measure it in the way that we measured reflex angles before. That means we have two options. You can either recognise that this bit here underneath the lines is 180 degrees, is a half turn, measure that little bit there and add it on, or we can measure the acute angle in here and take it away from the 360 degree full turn. Either is acceptable, whichever you prefer. If we go for the first option, they measure this little bit here and add it to the 180, then we are going to put our protractor on the line with the cross at 0. If we go for the first of those two options and measure this little bit here, and then add it on to the 180, we're going to put the protractor on B with the cross at B and the 0 on the north line. Then we are going to measure round until we hit this line here, which is going to come to, well, also 115 degrees, which makes sense. Because looking at A, they seem reasonable. We then need to add that on to the 180 degrees, and 180 degrees plus the 115 is 295 degrees. Alternatively, you may prefer to measure the acute angle in here, in which case then we are going to have our protractor facing the other way round, still with the cross at B and the 0 on the north line. We're going to measure round to that line here, and we're going to get that that is 65 degrees there. 360, take away the 65, is also going to be 295 degrees. Besides having to measure bearings, you might also have to draw something on a map at a particular bearing. The accurate scale drawing shows the positions of boat A and boat B. Boat C is on a bearing of 065 degrees from A. Boat C is on a bearing of 315 degrees from B. On the diagram, mark with a cross the position of boat C on the diagram. Well, this time we've got A and B marked and we've got north arrows given to us. We have not got a line between A and B, and actually in this case we don't need one, because we are not looking at the bearing between A and B or between B and A. We are looking at an extra point that is not marked on the map, which means we have to mark those two bearings on. So let's do the 0, 65 first. So boat C is on a bearing of 0, 65 from A. So we're going to put our protractor at A with the cross there and the cross from A and the 0 on the north line. And we're going to read around that 0 scale, the outside this time, until we hit 65, and I'm going to mark 65 there. That is where the 65 will be. I need to draw in that angle now. So I'm going to just draw a nice line to there. I don't know how long to make that, but it doesn't matter. As long as it's long enough, we should then get, once we've filled in the other line, a point where the two lines cross, and that must be where C is. Boat C is also on a bearing of 315 degrees from B. So we need to go 315 degrees clockwise from B, which means we're going to go round the outside. Now what we could do, because that's going to be hard to measure, we could either mark the 180 degrees on and then measure the extra, or we could measure the bit that we don't want. 360, take away 315, well that will leave us with 45 degrees still to fill. So if we measure 45 degrees in the other direction, so round to the 45, so here's our 0 on the north, round to 45, put a little mark there, that's 45 degrees, which means round the outside we must have gone 315 degrees clockwise. If we've measured the acute angle on the inside, the 45 degrees here, we must have gone 315 round the outside. This point here where the two cross must be C.